Hello everyone, this is Dinesh Kumar from iitiansgateclasses. So in this session, we'll be discussing about GATE 2022 paper solution for GATE 2022 Aerospace Engineering paper solution for aircraft structures part. From aircraft structures part, there are 12 questions from basics, aircraft structures basics and involved structures. 6 are for 1 marks and 6 for 2 marks. So total marks are 80. And in this, I have included only questions from SOM basics and involved structures. Mechanical vibration part I will be doing separately. So if you look into the this first question from aircraft structures basics, a beam wave symmetrical T-shaped cross section as shown in the figure is subjected to pure bending. The maximum magnitude of normal stress is realized. So you can see it's a T-shaped beam. For this is the T cross section. So they asked where your bending stress will be maximum. So we know the bending stress formula. So it is sigma equal to m upon I into y. So usually your sigma is max on a section where your I is minimum and your I is measured from centroid. It is measured from centroid. Now, in this question, if you see for this cross T cross section, your centroid T cross section is symmetric about y axis. Okay, it is symmetric about y axis, and your centroid will be somewhere closer to junction point. So for T section, this is your junction point. So somewhere here you will see your centroid. So that means if you take the distances of top fibers and bottom fiber from centroid. So what we see, your y bottom is greater than y top. So that means your sigma bottom will be greater than sigma top. So the maximum bending stress will be occurs only at bottom fiber of the cross section. So B will be the correct option. In this case, B will be correct option. Now look into this question. A three-member truss is simply supported at Q and R and loaded at P by a horizontal force F as shown. The force in QR is. So guys, if you look in this, it's a very simple question from truss and we can solve this doing without much calculation. So since this force is F acting at P, it will be reacted and where it will be reacted? It will be reacted on Q. Why? Because R is a roller end and it is a roller along horizontal direction. So the horizontal reaction at Q is what? F, and it is going away from Q in this direction. Now, if you take summation of forces in horizontal direction at Q, so what we find, your F will be equal to, if you take the reaction in this QR, so RQR. So they ask what the force in QR. So it will be what RQR. If you take magnitude is F and nature will be tensile. Nature will be tensile as the force is going away from this joint. Okay. So B is the correct answer. There are other way to solve this question. People might have used first they will find what is the force in this member and in this member, and then they resolve at point R or at joint. Now look into this question. The closed thin-walled rectangular channel shown in figure 1 is opened by introducing a sharp cut at the center of the bottom edge as shown in the figure 2. which one of the following statement is correct? So you can see the initially it's a closed section and then there is a sharp cut. Okay, and it has become an open section. So when we find centroid, usually in this case, you can see since it's a doubly symmetric and it's a closed section, so centroid and shear center is the same, this point. But if you look this case, if I take this as a reference and if I try to find centroid, so centroid mainly depends on the area distribution. So when we are cutting this section, this closed section, still you can see the area distribution is same. Okay, if you take this as a reference system, so your centroid still will remain same because we are not changing the position of the members. Okay, so area is still distributed in the same way. Okay, so in this case, your centroid will remain same, but when you make a cut open section, your shear flow distribution will change from closed section to open section. So your shear center position will change. Usually for this, your shear center will be lying somewhere on left of this top. Okay, somewhere here. Okay, you can say this will be somewhere your shear center. Okay. So if someone asks how to find the shear center position, you can apply one force in this direction and find the first shear flow for this, and then take moment analogy about this point. You can find shear center position. So if you see the correct answer, the answer A is correct. Centroid of 1 and 2 coincides, while shear center do not. Now this question 28. Let sigma and tau represent the normal stress and shear stress on a plane, respectively. The Mohr circle that may possibly represent the state of stress at a point in a beam of rectangular cross section under pure bending. So, guys, when pure bending happens, suppose this is my beam and uh, take any cross section. They already given it's a rectangular cross section. So this is beam under pure bending, and this is what your cross section, guys. Okay, the cross section is rectangular cross section. So guys, we know in case of pure bending, suppose this is what my z axis. Okay, cross section null axis are x and y. You can take. So in this case, you'll see only you have one non-zero stress in case of pure bending, it is sigma z. But if you see the variation of sigma z along z direction, it will be compressive on top and it is tensile on bottom. So at any point, either at any point on cross section, either you have a tensile normal stress or you have a compressive normal stress sigma z alone. There is no other stress. Okay, there is no other stress. Okay, so that means if you draw the Mohr circle, if you draw Mohr circle, it is case of uniaxial stress. Uniaxial stress. Okay, so if you draw your stress element, it will be like this. This is sigma z, and there is no other stress. So if sigma z is tensile, your Mohr circle will be C. Okay, because from origin, you have to draw this sigma z. So this will be center, radius, and you can draw a more circle which will pass through origin. Now, if sigma z is compressive, your option B will be correct, like in on the top side where you have a compressive stress. So B will be correct option. And now look into this question number 29, guys. An isotropic linear elastic material point under plane strain condition in XY plane always obeys. So these questions can be, repetitive from earlier years, like from 2008 or 2009. So you can see for a plane strain problem, for plane strain problem in XY plane, out of plane strains are zero. So that means your epsilon zz is equal to gamma xz equal to gamma yz equal to 0. And we know for plane strain problem in xy plane, your sigma zz will not equal to 0 because your epsilon zz 0, and we know sigma zz will be coming as mu times sigma x plus sigma y, or you can say sigma xx plus sigma yy. So correct options are A, C and D. So it is the MSQ. And if you take previous problem also was MSQ 20 number 8 problem, and more circle was asked first time in GATE aerospace. Now take question number 33. So very easy questions from stress transformation. So what is given? The two-dimensional plane stress state at a point is sigma xx equal to 100 and 110 megapascal. Sigma yy is 30 megapascal, tau xy equal to 40 megapascal. The normal stress sigma n on a plane inclined at 45 degree, and they measured angle from horizontal as shown in the figure. So usually we take angle from vertical. So if this angle from vertical is 45, so you can measure this angle. This will be also 45. So we know from stress transformation, your stresses in xy directions are given. If you find stresses which is at 45 degree angle, okay, and this 45 degree angle is measured in anti-clockwise direction. So this is sigma s, this is sigma t. Now what is asked? This sigma n is what? Sigma s, and we know from our stress transformation matrix. If I write my matrix, what is sigma s, what is sigma t, and what is tau st? So this is nothing but it is c square s square 2cs s square c square minus 2cs minus cs c square minus s square. Okay, and this is what sigma x sigma y tau x. Now many people did mistake, they used sigma t. Okay, sigma t was not asked. What was asked? Sigma s. So what is the sigma t? Someone say what is the sigma t? So that is nothing but if you take this plane, so on this normal to this plane will be sigma t, where you can see again this angle is 45 degree. This will be your sigma x, this will be your sigma y, and then corresponding shears. Okay. Now, if you want to find sigma s, which is asked here, so what it is? It is sigma x cos square 45 plus sigma y sine square 45 plus c square minus s square. Okay, or sorry, 2cs. So 2cs is what? 2 cos 45 sine 45. Okay, and it is tau xy. Now we know cos 45 is what? 1 by under root 2. And what is the sine 45? If you take sine 45, it is also same 1 upon under root 2. So when we substitute, what we get? Sigma x. And what is sigma x is given? 110 divided by 2, then 30 divided by 2, then 2 by 2 into 40. We know cos 45 into sin 45 is what? 1 by 2. So these two got cancelled. And so you will get here 55 plus 15 plus 40. So it is 110 megapascal. Many people might have got answer as 30 megapascal if you use this formula. So many people may not be knowing. They may know formula, but what is args? So in this case, the args was sigma n, which is nothing but from your stress transformation, sigma s, if you take s and t as a new coordinate system. Now this question number 41. So this is again a question which is repetitive from GATE XC question paper, and it was given in IGC assignments also. And if you take previous questions, similar question was there in K 2014 or sometime from stress transformation with the four option given. So this. So best way to solve this question number 41 is strain energy method. So we'll solve that. What is given? Read this question. A horizontal load F is applied at the point R on a two-member truss, as shown in the figure. Both the members are prismatic with cross-sectional area A naught and made of the same material with Young's modulus E. The horizontal displacement of point R is. So as I told, from strain energy method, we know you want to find delta R in horizontal direction H. So from strain energy or Castigliano's theorem, it is nothing but dou U by dou F. Total strain energy in this system differentiated with respect to load in that particular direction will give me displacement in that direction. Now to find this total strain energy, what we require? We require length of these members as well as the forces acting on these members, PQ and QR. So to find length, you can take this triangle, guys. So if this is 45, this will be 45 degree. And we know if you write cos 45 degree, which is equal to this will be equal to what? Base upon hypotenuse. So hypotenuse is unknown. So it will be what? Base is what? L. So it will become under root 2L. So the length of each member is what? Under root 2L. Now to find forces. So what we have to see? If this angle 45, this 45, so this will be 45. And this angle is also 45. Now guys, we will solve by truss method joint. Now suppose guys in this member my reaction is R1 and in this member my reaction is R2 and we know these angles already 45 degree. This is also 45 degree and this applied force is F. Now if you take summation of forces in vertical direction, what you get? You get R1 sine 45 plus R2 sine 45. So from here, what you see, your R1 is equal to, and this is equal to what? 0. So your R1 is equal to minus of R2. Now guys, if you take the summation of forces at R in horizontal direction, is equal to 0. So what you see here, you will see R2 cos 45 is equal to F plus R1 cos 45. So from here, from this equation, if you find your R2 will be R2 will, so you can substitute here. Instead of R1 minus R2, so you'll get 2R2 cos 45 is equal to F. And from here, if I write, what is my R1, R2? My R2 will be F upon under root 2. If you solve this, From here R2 you will get F under root 2 and it is equal to minus R1. Now we know for an axially loaded member, now we already got the member forces we got. These R1 and R2 are what your member forces. Okay. So now we know what is the strain energy stored in member PQ. So UPQ, UPR, your strain energy stored in member PR. So we know it is what? It is N square L upon 2AE. Okay. Now we know the N is what your R2. Okay. N is what? R2. Same way, uh, strain energy is stored in the member UQR. This is also N square L upon 2AE. Now you know areas are A naught and Young's modulus is E. Okay, and we know what is the N for member. What is the N for member PR? It is R2. And what is the N for the reaction force in the member QR? It is minus R1. Okay. So find total strain energy. If you find, it will be summation. So what it is? It will be F square L upon 4AE plus F square L upon 4AE. I have substituted values of NPR and NQR. So you can say it is NPR. This is NQR. Okay. So you find total strain energy stored in this is what? F square. Now length. So I have written L, guys. This is what the general formula of strain energy. But guys, the length is not L. This is L. So you can say this length is some new quantity you can take A. Okay, and this is in symmetric. So this will be also A. In this formula, it should be NPR square A, and this is also A. So you can write better, it is A. Now when you sum it, F square, and what is the A? A is your hypotenuse. We have already found this. This is what your A value. Okay. So F square, when you sum it, F square by 2 under root 2L upon A naught E is what your strain energy, total strain energy stored in this structure. Okay, guys. Now we know the formula. What is the your displacement in horizontal direction? It is dou u by dou f. So when you differentiate, so delta r in horizontal direction, when you differentiate with respect to x, you will get 2f under root L upon 2A naught L. So from here 2 got cancelled. So your answer will be coming as under root 2 FL upon E A naught. So C is the answer. So this question, okay, may not be done by many people, or you can say it may be done by very less people. It can be a bit lengthy, but if you know concepts, you can solve this question. And since it's a question similar to GATE exit previous year's question, so those who have focused on GATE exit question paper, they might have done. But in IGC, we have given this question already in assignment sheet. Yeah. So if you look this next question, what is given? Given the tip deflection and tip slope of a tip loaded cantilever of length L are this NL cube upon 3 EI and NL square upon 2 EI respectively, where N is tip force and EI is flexural or rigidity. So whatever this data is given, you will come to know these are just for beauty of the problem. So what is next given? A cantilever PQ of rectangular cross section is subjected to transverse load F at its midpoint. The two cases are considered as shown in the figure. In case one, the end Q is free, and in case two, Q is simply supported. So initially it's a cantilever beam with the load at mid, and then in second case it's a prop cantilever beam. What is that? The ratio of magnitude of maximum bending stress at P in case 1 to that in case 2 is. So guys, if you look in this question, we know what is my bending stress at P. If you take sigma P, it will be M upon I into Y. Now guys, for this given beam at P, your Y will remain same, your inertia will remain same. If you compare with case 1 and case 2, what is changing? Your moment will be changed. So if you take the case 1, your moment 1 will be what? At point P, it will be F into L. Now in case 2, you have to find moment. So what it will be? It will be what? FL. Okay, this force is downward. But here there will be a reaction force if you remove this roller support. So this reaction force is going in upward direction, so will give opposite moment. So it will be, suppose reaction is R and the length is 2A. Now how to find this R? We know to find R, your delta Q is 0 for case 2. The deflection in vertical direction at Q will be 0. So we know, those who have learned in ITC, this reaction R will be coming as what? 5F by 16. Someone will ask me how I got. If you take the case 1, your delta at free end will be what? 5 by 48 F L F into 2L cube upon EI. So this is the standard formula. When you have load at mid of the beam and what is the deflection at free end of the cantilever. Now guys, when it is a prop cantilever, the deflection due to this reaction, if you take delta Q into R, will be nothing but R into length is 2L cube upon 3EI. Okay, so when you equate this to this, as delta Q is 0, we will get reaction. So we will substitute this in M2. So it is what? FL minus 5 by 16 F into 2L. So from here, your M2 will be coming as 5 FL by 8. Now guys, they ask the ratio of maximum bending stress for case 1 to case 2. So sigma 1 P upon sigma 2 P is nothing but your M1 upon M2. So what is your M1? Your M1 is FL, then your M2 is 5 FL by 8. So it is nothing but 8 by 5. 8 by 5. Not 8 by 5. If you solve this, you will get 3 FL by 8. M2 will be 3 FL by 8. So it is 3 FL by 8. So answer is L by 8 by 3. 8 by 3. So guys, again check. Your M2 is 3 FL by 8 Okay, so M1 by M2 will be 8 by 3. So 8 by 3 is nothing but 2.67 is the answer. So let's see in this question. Next question, and this question is simple and a bit easy. Good question. A simply supported aluminum column of length 1 meter and rectangular cross section W to T with T is less than W is subjected to axial compressive loading. Young's modulus is 70 gigapascal. Yield stress under uniaxial compression is 120 megapascal. The value of T at which the failure load for tilting and buckling coincide is. So guys, we know for simply supported beam, what is your P critical? It is pi square EI by L square. Now guys, we know here I will be minimum, I minimum. So in this case, since the W is greater than T, so I minimum will be WTQ by 12. Now guys, if you find sigma critical, the critical stress due to buckling, it will be what? P critical by area. Now, what is the P critical? It is pi square E WTQ upon L square. Now, area will be W into 2 into 12. So, you will find sigma critical here is pi square E T square upon 12 L square. Now, guys, they mention find the value of T. So, your failure load for yielding and buckling coincides. So, and they also given sigma yield stress for compression is 120 megapascal. So, that means at failure, sigma YC is equal to sigma critical. So if you equate, you keep all the unit is in mm because the answer asked in mm. So 120 megapascal, and we know 1 megapascal is equal to 1 Newton per mm square. So 120. Now equate this. So this is equal to pi square. E is how much? 70 into 10 to the power 3, and T is unknown. Why 17 to 10 to the power 3? Because it's in gigapascal. So convert it in megapascal. Now 12. Length is given as how much? It is given 1 meter. So in mm, it will be 1000 whole square. So from here, if you find the T value, by simplifying this, your T value will be coming as 45.65 mm. So you can see it's a simple and easy good question. If you see these kind of questions, previously they have plugged in gate aerospace, buckling with thermal loading. Okay. So here in this case, they have clubbed your buckling and yielding. The process of solving problem is more of same. So we have done similar questions for thermal loading yeah, with the buckling in our classes. Okay, this question is bit lengthy. Read the question, guys. A 0.5 meter long thin walled circular shaft of radius 2 centimeter is designed for an axial load of 7.4 kilonewton and a torque of 148 newton meter applied at tip as shown in the figure. The allowable stress under uniaxial tension is 100 megapascal. Using maximum principal stress criteria, the minimum thickness T of the shaft so that it doesn't fail, and it is asked in mm. So guys, if you see this problem, here there is a shaft, circular rod or shaft, you can say, or it's a thin walled shaft. Now it is subjected to two kind of load. One is axial load and one is a torque. So, from axial load, you will have a axial stress. So, your axial stress, if you find the load is tensile, so you can say sigma A is what? It is P upon A. Now, given answer is asked in mm and unknown is thickness. So, your area, now what area it should be? It should not be a cross-sectional area. When you find axial stress, for a thin section, it should be material area. So the load is how much? It is 7.4 into 10 to the power 3. And area will be how much? It will be 2 pi. And what is the radius? See, the diameter is 2 centimeter. So your radius will be 20 mm. It will be 20 mm. Okay, so you can say it is area is 2 pi r 20 into thickness t. So this is what your axial stress. Now, if you see, it is also subjected to torque. So you will have torsional shear, and torsional shear your tau max, which will be on so what it will be, so it will be T by J into R. Now what is the J for thin wall? It is 2 pi R cube T. Okay, and it is multiplied by R, so you can say it is T upon 2 pi R square T. Now we know already axial stress, and it is coming as my axial stress is coming as 58.88 by T. And if you find your, after substituting value of the torque and radius, your tau is also coming as 58.88 by T. Now guys, they asked to use maximum principal stress per activity. So that means at failure, we know your sigma y will be equal to sigma 1, maximum principal stress. Now we have to find principal stress. So if you see this shaft, okay, it is fixed, here. Okay. Now if you take your stress element, you can see, if you take this stress element on surface, there is a axial stress and there is a corresponding shear stress. So if you find your principal stress, sigma 1 will be equal to, in this case, there is no circumferential stress in this case, because you have only normal stress which is in axial direction. So your sigma 1 will be equal to what? Sigma A by 2 plus under root of sigma A by 2 whole square plus tau square. Now we know sigma 1 is equal to sigma y, and what is the sigma y? It is 100. So if you solve this, it will be, after substituting this value of sigma A and tau, you will be getting 95.28 by T. Now they ask what is the T. So T comes to be, they ask what is the value of T. So from here, if you see, your T will be coming as 0.9528. But they ask answer is in nearest integer. So the nearest integer to 0.9528 is what? 1. So the answer is what? 1 mm. Answer is what? 1 mm. So guys, look into this question. So the previous question was a bit calculative, but this question is straightforward. Not much calculation, but very good conceptual question. What is given? A 10 kilonewton axial load is applied eccentrically on a rod of square cross section 1 centimeter by 1 centimeter as shown in the figure. The strains measured by two strain gauges attached to the top and bottom surfaces at a distance of 0.5 meters from tip are epsilon 1 and epsilon 2 respectively. The eccentricity in the loading E and they asked in mm. So you can see this question is similar to one question was asked in either in GATE 2018 or in 2019, where they applied one load on circumference. So here instead of circumference, load is applied at some eccentricity. Let's see somewhere here. So this E value is asked. Okay, this eccentricity value is asked, but on what basis they asked? They given strain at these location. Okay, so you can see here what is the given epsilon 1 upon epsilon 2. So it is given as ratio. If you find it is 0.016 upon 0.014. So it is comes to be 4. Now guys, if you look, when there is a load applied at some eccentricity and when you shift this load to central line, it will be shifted with the moment. So this is P and this moment will be P into E. Now you can see this moment when this load is applied above your neutral axis, this load will create fogging on top. So you can see here there will be tension due to this bending moment and here it will be compression and the given axial load is tensile. So this tensile load, axial load on this and this both location will give me tensile stress. So if you find your sigma 1, it will be what? It will be P by A plus M upon I into Y. So you can say this is axial stress part and it is bending stress part. But if you take sigma 2, it will be what? It will be P by A minus M upon I into Y. Now guys, we know from Hooke's law, if you find sigma 1 by sigma 2, it will be nothing but epsilon 1 by epsilon 2 because we know what is your sigma? It is E capital E times epsilon. Now guys, you already know these, so substitute here. So what you find? P by A plus M upon I into Y upon P by A minus M upon I into Y, and this is equal to 4. So if you try to solve what you say, you will get 3P by A is equal to 5M upon I into Y. Now, since the answer asked in mm, again, guys, I will convert all the unit in mm. So here, guys, write 3P. I will not substitute P value because you guys will see this will cancel. Now, area. So it is given 1 centimeter by 1 centimeter. So it is nothing but 10 into 10. Now 5. What is the moment? It will be P into E. So this P got cancelled. Now what is the inertia, guys? It's a square cross section. So for a square cross section, your inertia will be A power 4 by 12. It is what? A. What is the A? Side of the square and it is given 10. So substitute here. So it will be 10 to the power 4 now by 12. Now what is the Y value? It is 5. Okay. So if you try to solve this, guys, if you solve, guys, this, what you see? From here, if you find E value, it will be coming as 1 mm. Okay, it will be coming as 1 mm. Now you guys can see, if you try to simplify further, your E got cancelled. So if you see your E value, so what is the E value will be coming? It will be, you can say, it will be 3 into 10 to the power 4 upon 10 into 10 into 12. Okay, and also we will be getting multiplied by 25. So this will be what? Your E value. Now you can say this got cancelled, so it is 4. So you can see it is 10 to the power 4 upon 10 square into 10 square, because 4 into 25 is 100. So you can say it is coming out to be 1 mm. So in this structures part, last question, here many people have done mistake because they have not done correct idealization. So what is given for a thin walled I section? It is very simple questions from engineering mechanics. Though the width of the two flanges as well as web height are same to be equal to 20 mm and thickness is 0.6 mm. They are what? Second moment of area above horizontal axis passing through centroid. If so, we know for I section, your centroid, if you see your centroid is here, okay. So this is horizontal x-axis, this is y. Now, guys, the first thing when they say thin wall, you have to do idealization on mean line. So when you do idealization on mean line, what you will see, the height will be increasing, because you will see this is the, if you say given the, if you see the given section, it is given as a thick wall. Okay, so at from midline you have to pass. So this web height, instead of 20, it will become 20, 20. It is a point 0.6. So your web height, if you see 0.3, it's a total. Uh, yeah, it's a 0.6 mm, 0.6 mm. So this will become 20.6. So height will become 20.6. Okay, this will remain 20 and this will remain 20. Okay, so guys again can check for mean line. So 0.3 mm came from this side, 0.3 mm came from this side. So the height became 20.6. Now your inertia is asked about horizontal axis. For so thin word, your I-axis will be what? For this section and this section, higher order term of thickness will be neglected. So that means what? If you take inertia will be same. So it will be 20 into 0.6 VDQ by 12. So this will be neglected from analysis because it's an assumption in thin word. Higher order term of thickness will be neglected. Then from parallel axis theorem, so area is how much? 20 into 0.6. Then, okay, I will write it down in better. So plus it will be 20 into 0.6 is area and the distance from centroidal axis. So this, it is 10.3 square, 10.3 square. So this is what inertia for this member and this member. Now for vertical web, what is the inertia for web about centroidal axis? It is plus B. So it is thickness is 0.6 into 20.6 cube by 12. So if you solve this, your inertia will be coming as 29. So the inertia calculation, if we do, it comes out to be, so the inertia calculation is comes out to be 2983.25 mm power 4 with thin wall assumption. Okay, if you don't do thin wall assumption, then also we can find directly considering thick wall. Your inertia, Ix, so that can be done like this. we can find the outer inertia of this complete. So it is like B. So in this case, thickness is 20. The height, total height will be 21.2 cube by 12 minus. So minus, now in this case, your thickness will be 19.4 into height will be 20 cube by 12. So if you do that way, your calculation, your answer will be 2946.88 power 4. So this is what exact calculation, and this is from inward calculation. So we have to wait and watch what answer will be given by GATE, our GATE community. So thank you all for watching this video, and we have upcoming batches for GATE 2023 and 2024 from Feb 20, and IGC provide best support, and most of the questions either these were covered directly in IGC assignments, mock exams, or during classes, or at least every concept was covered in IGC work. So thank you all. Thank you.